Okay, kids, so today we're going to learn about discrete math, probably the most important type of math in computer science, as well as, just general mathematics and just life in general, even if you never use it. Who gives a shit? So, we're going to do 1.1, lesson 1. So, essentially what this is we're going to call this lesson math logic, the very basics of math logic. We're not going to get into Boolean yet, but we are going to get there eventually. I just want to give you a few symbols. So, there is symbols for certain words like and, or, XOR, which we'll learn about later, NOR, and NOT. So these are just the symbols you would use. You would use like a caret for AND, an upside down caret for OR. You would use a circle with a cross inside of it for XOR, because let's murder Jesus, right? Okay, and then NOT, we're just going to do a little squiggly line, like approximately. And then NOR is actually, you're mixing two things together, so you're actually going to get this symbol. So those are all the main symbols you're originally going to use. Now we're going to learn about order of operations. So let's say we have an example of how this works. So AND, let's say you have two things together. Something is true and something is false. We can actually make what's called a truth table. And we're going to have this. So we're going to have where T and false, true and false. We're going to have true. This should be an and false. Sorry about that, guys. True or false. We're going to do a true X or false. So these are called second order logistics. We're going to go over also first order logistics in just a little bit, but an example of what this would look like is something that's true and false. What this is going to eventually look like is false, because true and false can only be true if both are true. Similarly, or only one of them has to be true, so in this case it is true. In this case, true X or false is true. But if we have another example, let's say we have true and true, true or true, and true X or true. This one is going to look a little bit different. It's going to be true, true, and false. So the reason this one's false, XOR right off the bat, is XOR can only be true if exactly one of the two options is true. It's false if both are false, and it's false if both are true. Or just means at least one of them has to be true, so that's why both cases are true. And means everything has to be true. And, just like Donald Trump, he can never get his way, so that's complete bullshit, but that's just the way it is. Cool, so that's all of that, and we're now going to look at what's called first order operation. There's only one first order operator. That's what the not up here is. So it's going to be, an example is going to be this symbol next to a not true means false, because it's a negation, so whatever it is next to is the opposite of what it's trying to be. Similarly, not false is true. That makes perfect sense, right? Not true is false, and not false is true. So we're gonna do some good time though here. Let's do our first main example, which is gonna be true and false, or true. Not 7 is equal to 10. XOR 7 is not equal to 11. Okay, so the first thing we have to do, the order of operations, is first parentheses, and then we do first order logic, and then we do second order logic. So it's P false all is the way we remember this acronym, okay? So remember, the first order logic is only the not symbol, and then second order logic is AND, or XOR, and obviously parentheses looks like this. So let's solve that. We solve it left to right. Remember, computers can only do one thing at a time, so we have to solve one section of it at a time, and then we're going to reduce it to a new line. So this is going to be true and false, or true. And then we're going to put, because there's no operator here, we're going to have to do the not next to it. So we're going to put out the not distribute. So this is going to be not 7 equal to 10. XOR, this one will be 7 not equal to 11. What we eventually then get is true or false, and true. And then we're going to do whatever it is not is 7 equals 10 is not true, so that's false. XOR 7 is not equal to 11, that's true. True. So now we have all trues and false, so we can go straight through left to right. So true and false is false, or true, not false. So remember, the next thing we have to do is first order operations, which is here. So is where we get a little bit tricky, because we do solve for this being that and that. That stays the same, but this becomes not false becomes true, but there's no other second order operation here. So what do? we take the one that comes before it and we add it on. So what we would get then is false or true because not false is true. And then we're going to get XOR true. Then we're going to move it on and we get false because, so for this one it's false or true, XOR true. And get that whole thing is eventually going to be equal to false or true, either way it's true, or true, XOR true. We then eventually get that this is true, XOR true, and we know that XOR true can only be true if exactly one of them is true, so that's false, so your final answer is false. All of life has no meaning. Thank you.